In a previous video, I talked about the lead acid battery that's in the Prius. And most conventional cars have, not most, but maybe all conventional cars have a 12-volt lead acid battery. What keeps that battery charged? Well, in a conventional car, an alternator keeps that charged, or you can think of it as a three-phase generator if you want to think about that. So, if the engine's not running, then you're not charging the battery. So, you definitely need the engine running to charge the battery. In a Prius, that's not the case. In a Prius, that's not the case. So, let's figure out what does charge the battery in a Prius. Okay, you get in the car and you want to start the car. That means you put your foot on the brake pedal and you press the start button. If you listen really closely, you can hear some clunks of relays closing and tying in the 206 volt battery. 206 volts because that's made up of multiple lithium ion cells that are about 3.6 volts each. So that battery, the 206 volt battery, is actually there to charge the 12 volt battery. Without that 12 volt battery in place, the car is completely dead. The high voltage is disconnected and all the other systems associated with the high voltage battery are not going to work. You can't start the engine because you need the electric motor that also drives the wheels, but also drives the generator. You need that to recharge the 206 volt battery and also to start the gasoline engine. So if you lose that 12 volt battery, you're completely gone. Now, how does a 206 volt battery charge a 12 volt battery? The charging voltage for the 12 volt battery from one of my viewers says it's probably about 14.4 volts because you want a higher voltage to do that. So where does the 14.4 volts come from? 206 volts all the way down to 14.4 volts. What are the electronics that make that happen? That's what I'm going to discuss in some pictures. Let's take a look at a box here that's under the hood inside or inside the car at the Toyota Prius. This is a DC to DC converter. So that's a pretty big box just to just to go from 206 volts down to 12. So what all is involved? Well, the first thing is you've got to have some high voltage electronics that are willing to handle the 206 volts. So that's part of the reason for the size of this. Now let's take a look at a very, very, very simplified version of the circuit. Here's the circuit diagram of what's called a switching supply or DC to DC supply. This little symbol here represents a silicon switch. So it's an FET, probably a MOSFET design or something. But anyway, just think of it as just a switch. That's just a switch. And if I have this positive voltage, we're going to consider that current's going from positive to negative, even though electrons are the carriers. It's much easier if we just treat this as positive to negative current flow. So let's just turn the switch on and see what happens. Well, I turn the switch on and this diode here won't let current flow. So this just acts like an open switch here. And then I go through this coil, which is just a coil of wire. And if I leave this thing on, what's eventually going to happen? Well, eventually the charge is going to build up on this capacitor, and we've got 206 volts out there, which is way more than we want. So we have to figure out a way to control this switch so that doesn't happen. What's the coil for? What do we need a coil for? Well, the coil uh, will resist change in current flow, and what it will do is it will switch polarities as soon as we turn this switch off. So let's see what happens. Well, I turn the switch on for just a short time, and then the current starts to flow, but most of the voltage is across this coil. Turn the switch off, and this reverses polarity on the coil, and the current flows back through this diode. So we don't allow the charge to build up any more than we actually have to. So by switching this thing on and off, on and off, on and off, we get just the right amount of uh, balance between this coil and the capacitor, and that's where we get that voltage. But remember, this fancy electronic stuff, that's what's charging the battery. So as long as your high voltage supply is on, you're charging the 12-volt battery, whether you hear the motor running or not. Here's a picture of a Toyota diagram that shows how this buck converter is used. Here's the buck converter with the coil and the capacitor, and this outside, or this particular point, is connected to ground and to the auxiliary battery. So the differences are because of the huge voltage drop that's required from the 201.6 volts. They had to use a step-down transformer. And this step-down transformer brings the voltage into a lower level that will work for that. So I added this little piece, wasn't on there originally, so that gives you a little bit more detail about what's going on. Here are the switching transistors and so on that give you a AC voltage that we can use with this transformer with.